Cheers. Thank you. Hello, I'm James. I'm a technical architect at the Government Digital Service. A technical architect at GDS is the developer that goes to all the meetings. Now, if I'd known he was going to use VI to present there, I would have used Emacs, but I've gone the traditional route, unfortunately. So this was a talk. It was originally going to be a description of the journey and mistakes I made when I was learning Go. I'm less likely to offend people if I point out my own stupidity, but then I realized I only have 10 minutes, and I don't know if I can talk as fast as he just did. So as an architect, I like to say that constraints are a good thing, so hopefully I've come up with a better talk as a result of only having limited time. So the talk has 4 main parts, really. First off, what is Go? It comes from the creators at Google. They were sitting around waiting for C++ apps to build, and they had hours of time spare. So you can target different environments. So you write the code, and it will build for Windows, OS X, Linux, Plan 9 even. Android and iOS is coming as well. So what's important about Go? What are the core ideas within it? So the main thing for me is something called communicating sequential processes, or CSP. Now, this comes from a computer science paper back in 1978 by a guy called Tony Hoare. But it's a computer science paper. It's not too scary, though. It's got 3 main things in it. The 3 main ideas are input, output, and concurrency, and how you can model computation as a series of mutually cooperating processes which run concurrently, and they participate in events, and they use I/O to join those processes together. So as an aside, just define the terms I'm using here. Concurrency and parallelism sometimes get confused. So that's a definition by a guy called Joe Armstrong, who's from Erlang, about what the difference is between concurrency and parallelism. Go actually gives you both. It gives you concurrency via a feature called the Go routines, which are in the language. They are the things that you use to model a computational process. And then the I/O scheduler within the runtime distributes all these Go routines across all the cores of the CPU. So in CSP, you have communication and synchronization, and they're equivalent. You communicate, and that's a synchronous mechanism. So you communicate by passing messages, not by sharing memory. So what do I like about Go? You don't have this. And why you don't have this is really interesting. So there's a tool called Go Format, which you run on your code, and it uses the features in the standard library for going, right, I have an AST of the code, I know how to print that AST. So that's defined as part of the language. You don't have formatting arguments, you just run that tool on your code. There's no more fighting over style guides. I had a look before I wrote this talk, and there's so many published style guides for C++. Google have got one, Stripe have got theirs, the Government Digital Service have got theirs for here's how you do Ruby, here's how you do other things. That's all gone. And because you have this AST available to you, it enables all these other things as well. You can get call graphs of how your code is being used. And this leads to other interesting tooling opportunities. So Martin Fowler, who wrote the refactoring book, wrote a thing about 15 years ago about crossing refactoring's Rubicon. And in it, he talked about how extract method refactoring, that's kind of the minimum height requirement for being a decent refactoring tool. And to implement that extract method refactoring, you need an AST. And within Go, the AST is in the language itself. So you can write tools in Go that manipulate Go. And that's a really powerful thing. Go also has a great story on backward compatibility. There's been a guarantee that for the 1.x release series of Go, it should just work. Now, Sun and later Oracle have worked really hard to maintain backward compatibility for things like Java. Go slightly sidesteps this a bit as well by the tooling that it offers. When Go was being developed early on, they were making breaking changes to the language quite a lot, so they wrote another tool that operated on the AST called GoFix. And this gives you migrations for code. You're probably all familiar with migrations for data, but this gives you migrations for your code as well. Go has a good story on testing. It's a modern language. It has a really extensive standard library, and testing is in the standard library. Other libraries are available as well. The community's built their own. But if you look there at the time for the tests, it's taken 0.19 seconds to run the tests. Tests are really fast in Go. And that's really great in terms of a feedback loop. When you're in the flow, you're writing the code, you want to see what your changes have made. That's a really fast feedback loop. It integrates with your editor. You also get code coverage as well from the tooling, so you can get detailed information about what's being tested, And you can make decisions about where you need to make the investments to get better test coverage. You can see which lines are actually being executed. So that's an HTML version of code coverage. Apologies for the green and red thing. That's a default, which isn't probably great from an accessibility perspective. But it shows me what lines are and aren't being tested, and I can make a decision about where I want to improve the code coverage or not, or do I really want to test a standard library that's already tested by Google. It's also got great support for benchmarking. That's built into the language too. So here I've got 2 benchmarks. The initial code was running at 10,940 nanoseconds per operation. They made a change, and that dropped by 20-odd%. So really good feedback again for that. But don't prematurely optimize people. Profiling too, great support for that. You can look at what's dominating the application, what's dominating the runtime in the CPU, where's all the memory bit going. You just write the code, you can instrument it, you can examine it at runtime. Here it's a tool that's similar to top, going, right, where is all the CPU time being spent? You can do similar things for memory, and there's a sort of inbuilt query language within the tooling for that. You can also get visual representations if that's helpful for you. So here, looking at the call graph and where the time goes. And recently, Go 1.5 was released, which introduced a new garbage collection. It's now concurrent. And this garbage collection was developed by people that have been working on garbage collectors for years. And it's intended to work for the next 10 years of hardware or more. Currently, you might be developing on a quad-core machine, and then deployed to 16-core machines in production. CPUs are only going to get wider, we know this. So with a concurrent garbage collector, it reduces the time to do all the garbage collections. So here's a recent graph showing garbage collection pauses over time. When your application's paused, and it's doing garbage collection, it's not actually doing any useful work. It's not doing things that your users want it to do. This is not a good thing. So here you can see the graph. Initially, the pause times were around 300 milliseconds. And then they introduced Go 1.5, and you can see that pause times have now dropped to 30 milliseconds. The last thing I like about the Go thing is it has great first-class support everywhere. Heroku has first-class support for Go. Travis has first-class support for Go. AWS has an SDK in it. It's a really widely used thing. But what's not great about Go? What are the little niggles? So often, language conferences will try and fill up the schedule to address the thing that language is most uncomfortable about. So if you go to a Clojure conference, for instance, you'll have a lot of talks about how people are running Clojure in production. Because who really runs Clojure in production? Anyone? No. I love Clojure, really. So the similar thing in that vein for Go is dependency management. Most software developers don't work at Google. But where Google operate, they have a thing called a monolithic repository. All of the source code is in a single source code system. And this works for them. There are various advantages in doing that. But Go is open source, and it exists outside of Google. And the Go curators didn't want to enforce Google's conventions on the world. So they punted and said, right, we don't know what the right solution is for this. And they waited for people outside of Google to explore the problem. So what do we have? We have lots of people in the community building a bunch of things, poking at the problem, seeing what's good, and then drawing those together. They're not blocked by Google. You can innovate without that. So that's going to be solved at some point, like it has in other language ecosystems. So what's Go good for? It's not a C++ killer, despite the intention of C++ builds being annoying. I think Rust is probably more likely to supplant things that were traditionally viewed as C++ projects, and Dan's going to talk about that later. People seem to be migrating from Ruby or Python instead. They like the expressiveness of Go and the succinctness, but they really like the performance as well. So Go is used a lot for cloud infrastructures, small tools that do the one thing well. Things like the company HashiCorp produces a bunch of great products like Packer, Consul, Terraform that are written in Go. The Hub command line tool for GitHub is now written in Go as well. Loads of people using it. So in summary, CSP is really powerful. And as someone personally that doesn't have a computer science degree, computer science isn't that scary. Go has fantastically great tooling, which is only getting better. Also, we're hiring. I got a bunch of links there for people that want to look on the slides afterwards. I'm done. Thank you.